you have to run in a single sequence. So in that, to reduce time, you can, if you know Python basics and know how to use these APIs, so you can directly dump them and you can run the sequence of simulation in, I mean, you can automate them and they will at a time give you the certain set of results. So there is definitely advantage, but I will not say it is something difficult to learn, but it's a additional skill, I can say.
Sir, definitely.
Sir, is that software available free, sir, or is it
Which one?
whatever the software you mentioned, sir, to PSS tool something you mentioned?
No, PSSE is basically mostly used by industries, so they don't provide free versions. But there are softwares similar. If you want to do power system simulation, there is something called Power World Simulator, which is open source software for academic purpose. But for PSSE, mostly either you take academic license or industry license.
Okay, okay, fine, sir. Thank you, sir.
Hello, sir.
Yes, sir.
Sir, can I speak, sir?
Yeah, please.
Sir, interfacing with the AI, is it HMI and SCADA is almost previous version we have to use or any recent version we have to use, sir?
The which one? Which version you are telling? The
Regarding artificial intelligence, we are adapting for power system means whatever the old power grids or recent grids, almost they are equipped with older version of SCADA and older version of sensors are to be replaced or any new same with the same system we need to improve that one.
So there are two aspects. If your existing SCADA already, let's say the control and communication will take into account. There are different standards are there, right? From Indian grid point of view,
Scenario, yes, sir.
different standards are there and different, you can say, communication framework and control framework are there. So as long as they are meeting the standard, you need not to change them. But of course, the new AI model you are going to develop, so if you can make them grid compatible or grid core compatible, then I think only that is sufficient to add them to the existing SCADA network or SCADA model, whatever the software you are using.
Okay, sir. Okay. Thank you, sir.
Thank you. So there is a question in the chat box, Ms. Punita, I think. Real-time simulations software for microgrid frameworks. So basically at IIT Dharwad, we have using the Opalati. You might know this Opalati company. So basically they call real-time simulation. So whatever the offline simulation you developed, then you dump them into a real-time simulator provided by the Opalati company. And that controller, you can actually interface the actual physical inverter to a actual grid. So that kind of, and they, of course, they provide their own GUI software. Like for Opalati, they give Actilia. There is similar something is there called ActiDS. So they use RSCAD simulation software to put the controller in real time. So those are the two, Opalati and TDS are the two trending real-time simulators, and also the company name also same. Yeah, so those are the platforms you can say. Did I answer your question? Okay, thank you. Hello.
Participants, any other questions?
So this whoever attended, may I know all are the like students are different level like faculties like research scholars are available, right? PhD or master level students. Hello. There is a hand raised from Mr. Sasidhar. Sasidhar, yes. Hello.
Sir, I have asked, sir. Just now I asked regarding SCADA and HMI. I am
Okay,
Shashidhar. Okay, sir.
okay.
Okay.
Thank you.
Thank you.
Sir, kindly provide your email ID so that we can call you as for the guest lecture, etc. in our college.
So I am typing in email, sorry, chat box. Is it okay? Yeah, I
Yes, sir.
typed
You
in.
can provide the email ID
Yeah,
in chat box, sir.
yeah, yeah.
Thank
Already
you so much,
given.
sir.
Thank you, sir.
Thank you.
Participants, kindly check the feedback form is sent in the chat box and WhatsApp group. Kindly fill it up.
Hello.
Yes.
Hello, sir. Good evening, sir.
Good evening.
Sir,
Yes.
I'm currently starting my research on energy management harmonic compensation decentralized control architecture, sir.
Okay.
How the AI can be applied for a decentralized control architecture, decentralized way, sir. How this technique will be much useful.
Yes, it's a good question. So I heard you mention something energy management, right?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So particularly when you consider a microgrid, let's say we have
Okay,
different
sir.
layers of control and different types of control. Okay.
Okay, sir.
So
Okay, sir.
then we classify the type of control mostly as centralized, decentralized, and distributed.
Okay,
And
sir.
when we say decentralized, mostly we don't use any kind of communication or some kind of low bandwidth communication. Okay. Now, when you
Okay, sir.
say microgrid control, we may mostly follow the hierarchical level of control. One is the primary control, secondary control, and tertiary control.
Okay,
Okay.
sir.
In primary control, mostly is to implement this local controller like power sharing, different PV inverters, then with different battery energy storage. Secondary control we use to mostly deal with the frequency and frequency and voltage magnitude deviations as a result of any kind of power sharing happening in the microgrid, and particularly in third layer, which is a slower controller action, where we do different kind of energy management studies like that demand response balance and all these things. So in your perspective, if you are proposing some kind of energy management principle, so there are different optimization strategies we basically use. So if you can pick up some or you can go through some literatures, what are the state of that optimization techniques that has been used, and what you can modify or you can come up with a different optimization algorithms based on your necessity like harmonic minimization or cancellation or some kind of technique, then in that perspective to deal with these optimization strategies, you can use some kind of, let's say, this forecasting thing I told. So that
Yes,
also
sir.
comes under this tertiary level layer where you forecast the solar power generation day ahead or month ahead or something like that. So in that case, you can use some kind of AI-based technique. As I told you, some brief. I gave you
Yes, sir.
brief about different techniques. So you can use some kind of optimization tools to predict the power output or predict the harmonic content or harmonic compensation techniques, and you can propose a new overall energy management strategy.
Okay, sir. Thank you so much, sir. Thank you, sir. Thank you, sir.
Kishore sir?
Yes, madam. Yeah, there is oftener is there. Okay, dear participants, let me show you something. Overleaf LaTeX is one of the softwares. Okay, so maybe I can conduct oftener is there. So I will explain about LaTeX. So I will first what I have to do. I have to share the screen.
So may I leave now, or what's the plan?
Sir, yeah, Animesh sir, thank you so much, sir, for your kind
Yeah,
speech.
so I think my slides were less to finish early. Anyway,
Yes,
so
fine, sir.
okay.
No problem.
Thank you. Thank you,
Thank you, sir.
everyone. Bye.
Yeah. Yeah, entire screen. So I am sharing my entire screen. All of you kindly see here. Sweta madam, is it visible?
Yes, sir.
Yeah, Overleaf. So Overleaf is one of the best softwares for the LaTeX. So I mean, if I have much time, I can explore you much, but still I can show you what are the things I have done. So this is Dr. Kishore, and I'm the coordinator of this program. So I have some good knowledge on LaTeX. So LaTeX is basically the already built-in program. For example, if I am running a journal or running a conference, my all submission from my participants or from the authors should be similar. That's what I expect. So for that, what exactly happened? If you go ahead with the Word file, it keep on changing in different fashions. Sometimes we don't know why this space has come. Sometimes we don't know alignment properly. But here, coming to LaTeX, you don't need to worry about anything. Okay, everything will come into picture automatically because it's a programming that will be done by the journal people and conference people. You no need to worry. For example, I like to show you one thing here. So I have done so many files here. You can see this is my account. All these files I have done. I have generally used for many purposes. See, you can see I have 142 projects done in this LaTeX. I generally use it for, I will just show you why I have used this LaTeX. I have generally used it for four things. Okay, the first one is paper, I mean research paper or article writing we can call. Second one is report. It is one of the beautiful concepts in LaTeX because report writing is very important and very easy in LaTeX. Okay, I will show you this part also. And the third one is CV. So we can prepare our resume in very nicely and very beautiful way we can prepare. And the fourth one is PPT. We can prepare the best PPTs out of this. Of course, the animation and different features are very well versed in MS Office. So we can't compete MS Office with the different animations and different skills. But here also we have some styles. Okay, the beauty of this one is LaTeX is really a programming language, but the beauty is being electrical and electronics engineering faculty and people working in industry, we no need to worry about the programming. Okay, just understand the programming, that's all. That's more than enough. Okay, for example, this is one of my notes I have given to students. So this is what we call as a report class. This class is called report class. Okay, of course, if I have much time, I can show you better. I can take a blank sheet also and I can keep typing and I can show you how best and how easily we can go ahead with this. Okay, but for time being, I will let you know what are the simplest forms of going ahead with LaTeX. So here document class is here. So document class means you have to say this is like a package. Okay, if you say article class, for example, \document class, if I write article in that, what are the things required for article that will come here? That means the structure will be like that. If I make it into report class, the structure will be like that. If I make it into some resume class and some other classes, the structure will be like that. And in resume, so many different classes are there, and it is a open software, so we can also start doing it, and I can also create my resume and I can publish openly show it to anyone, and I can give it to anyone to make it. I can name it as KISS CV, for example. So in place of report, I can write KIS CV. Okay, if I write that, whatever I have prepared, everything will come and sit in your computer, and you can just change the names in and there, and you can clear it. Okay, I will show you what I feel the best out of this LaTeX. Okay, this is the one of the report class. So as this is the report class, I like to show you another best example out of this, because I have done a great, not great, I feel that it's like a textbook kind of thing. So what I have done here, I will show you. This is the report class, so you no need to worry about anything. I will just let you know one by one. So this is a report class. That means I'm preparing it as a report. So what is the beauty of this report class? I will show you. So the report class looks like this. Yeah, report class means something like title will be there and subtitle will be there. I will show you one by one. You can see here title. So for each and every LaTeX program, we should have backspace document class. We should first define this. Okay, so I have defined this class as a report class, and these are called some packages we have to bring in. So don't worry about all these packages. And the thing is, we should have some title. So backslash title will be there, and like this I have written something. This is renewable energy class. We have given it to MBA students, so that's why I have made it into this much polished way. And once this part is over, we can write author name also. See how nicely I have portrayed my name, designations, and you can observe this. Okay, everything will be done by this one only. Okay, you can give small, big, bold, slant, I mean italics, whatever you want, you can give it. So anyhow, I will show you what exactly the thing for every class. All these are all user packages. Okay, no need to worry. Yeah, from here my programming starts. Backslash begin document and backslash end document. So whatever I want to see here, it should be in between these two only. Okay, and maybe author, title, these should come inside this by using a simple command that is called backslash make title. Okay, I really fell with LaTeX because of the only two commands. Those are table of contents and list of figures. Maybe many of you people might have completed your MTech and BTech. So in those MTech and BTech, you might have written your thesis or dissertations. So everyone knows that what is the difficulty you are facing in that. Correct? What is the difficulty you are facing in that? For example, I am writing my PhD thesis. in second chapter, I have 50 diagrams. So I have shown to my guide, and my guide suggested me, Kishore, please remove 21st to 30th diagram and try to include some 10 diagrams after 40th. So how much, what we can do now, 21 to 30 diagram I need to remove, and for 31st to 40th diagram I need to change the name from 21, 22, 23, 24, 30, like that. Correct? Then I need to add them. Every time I need to change, for example, simple example I will tell you. I have 50 diagrams. If my guide told me to remove second diagram, third diagram should be changed to 2, fourth to 3, fifth to 4, like that. How many changes I need to do? Am I right? Is it difficult? Yes, it is really difficult. But it is very easy in LaTeX with simple table of contents, list of figures. Okay, these two are for getting table of contents and list of figures. Without these two also, numbering will be automatic in LaTeX. Numbering will be automatic in LaTeX. For example, I have given a photo, and I have given second photo. So first photo number will automatically come as figure 1, second photo number will automatically come as figure 2. Okay, if I have another photo, I want to keep in between these two. Now the second photo will automatically be as figure 3, and whatever I am including in between these two, that will be 2. It is an automatic thing. Understood? So that is the beauty. You can see how nicely it has come. It looks like a textbook only. I don't do much about this. Whatever, I have simply copied the data and post here. That's it. Okay, I didn't do anything much about this, but see how nicely it has come. Okay, with only one command we can get this beautiful thing. Okay, that is / table of contents. That's it. With only one command I can capture all the topics, subtopics, subtopics, and also with page numbers. So that is the beauty of LaTeX. So at least for book writing, those who are writing the books, those who are willing to produce very good reports, kindly follow this. This is very, very easy, because I never expect that LaTeX is this much easy. With one command everything will be compiled. Can you do? How much time will you take for this contents? If I give you this this complete document, how much time will you take to do this one? Definitely it will take more time, because every time you have to see, for example, power in excuse me, power in wind is there. Okay, it is in 11th page. Okay, so can you by heart site selection in 12th? No, you have to come here, you have to write 11 again, you have to go to site selection and you have to make it 12. Suddenly if I show this to my guide, okay, he may say that here you add 2 pages. What happened to all these things? You have to change. In Word file you have to change all these things, but in LaTeX no need to change. You no need to change. Okay, that is the beauty. Understood? I will show you for your clarity. So let me take the wind energy system. It starts from 11, it ended at 13. Okay, for example, in between that I will add something. Where is wind? I will show you. Wind energy, periheliometer, sunshine recorder, wind energy, fundamentals. Okay, just concentrate. It is very easy and fully entertained also. See, this is wind energy. Okay, for example, you please make a note of this. Wind energy starts from 11 and it ended at 13. Okay, for example, if I increased this one, I have some data, so I want to, for example, I will take this one only. This table I am taking. Just to increase the pages. Okay, I am simply showing you, if I increase the pages, what will happen. Okay, this is a table. I want to copy. I have copied and I want to paste twice. Okay, please make a note of this. Okay, wind energy is from 11 to 13. Okay, and you can make note of this one also. This table is there. So this table may be the last table, list of figures. Oh, list of tables can also be there. Okay, I didn't mention here, I think. It's okay, no problem. Let us leave it. Yeah, so two tables I have added. So obviously the wind energy page number should change. Okay, so please make a note. It is from 11 to 13. Now I am recompiling. You just see how it will be changing. It is still that one only. Maybe. Okay. I will go to page and I will see. Okay. So I have added twice, but it is not sufficient. Okay. Anyhow, I will show you one more thing. Table 1.2, table 1.3, table 1.4. Understood? So this is the way it is coming. See, it is nicely sitting in the same page only. Okay. But anyhow, I want to do one more time. Okay, I'm adding one more thing so that it will change now. Yeah, let us see the change there. Okay, it is 11 to 13 previously. So now it will be, it should be from, starts from 12 or 13. See, it starts from 12. Is it visible? Yeah, is it visible? Now tell me, dear participants, is it not great? Okay, so what I am doing, I am simply adding the data. That's it. I am not coming back to contents. I'm not doing anything else here. I'm simply adding data wherever required. That's it. I'm simply sleeping. But if you do the same thing in MS Word, what you have to do? You have to go back to contents. You have to type it, or you have to change the page numbers. For example, wind energy page number is changed from 11 to 12. Means what? All downward numbers will be changed. Correct, no? So this is the beauty of LaTeX. Okay, so this is I have extensively used for notes preparing. You can see how best the notes will be. You just see the appearance also. See how nicely it has come, how nicely it has aligned. Okay, I didn't put any much efforts. Okay, I simply how we can write the notes by seeing the textbook. Okay, like that only I have taken some points and I have simply typed it, or I have simply copied it. Understood? But the thing is, that is the greatness of LaTeX. And here we have to, the most powerful things here is insert a picture, how to insert a figure that you should know, and how to insert table that you should know. But again, the beauty here is inserting figure is not a big deal. Okay, you can just get the figure here and you can keep it. But table preparation is a big deal. Okay, it is a complete, you can see the comments and everything here. Completely, it's a very big programming. Okay, you have to learn a lot. Fine, to make this table. But we have a technique. Okay, people are there. They are readily making. They are helping us. Okay, one website is there. If you go to that website, you can make the table nicely. Understood? Very nicely, you can make the table. Right? So this is the case, and so those are the things. Other things also, if we, I mean, if time permits, we will keep discussing. Okay, not an issue. So let me go back and show you another beautiful thing. Maybe 10 more minutes are there. So let me go back and show you another beautiful thing. What shall I show you? This is also same cycloconverters. So this is also in notes only. Electrical simulations. This is also notes, and you can see this CV resume. Yeah, this is a modern CV. So this particular class is called modern CV. You can see how nice my CV is visible. Okay, so it is the structure actually. This is the structure of modern CV. So the structure will be like this: education qualifications. Qualification will be here, and affiliation will be here, and you can see work experience. Date will be here, and experience will be here. You can see the things also. Associate professor, it is in bold. JAIN deemed to be university, it is in up to university, it is in what we can say italics. After that, it is normal, and other things are normal. Understood? So these are the different category. Okay, what is the beauty of CV means with only one command you can play the game. One command gives you 6 components of different things. Maybe this is one component of this line, and this is another component of the line, and this is another component like that. I will show you. You will simply surprised. Only one command. That command is called CV entry. Yeah, I love this command. CV entry. Okay, CV item is also there, but instead of CV item, if you in place of CV item also you can make use of CV entry. Okay, CV entry means it will allow you to give 6 different data. For example, I have given one data here: 1, 2, 3, 4, 5, 6. I have given 6 different types of data here. If, for example, you don't have data, okay, just make the curl braces open. That's all. Out of 6, you make anything open, then it will work out. Understood? This is the beauty I have identified. I feel comfortable in CV. But for example, if you call me as a resource person to explain the LaTeX, so I should show you different things. No, so that's why I have taken CV entry here, CV item here. But frankly speaking, the CV item can be replaced with CV entry. Of course, converse is not true, because CV item is only to enter 2 data sets, but here 6 data sets you can enter by using CV entry. Understood? So this is the beautiful thing I have observed from the CV. And let me check whether sir has joined or not. Sweta madam?
Sir?
Did sir has joined, madam?
Checking, sir.
Yeah.
Raghu sir is there, sir.
Raghu sir is there. Raghu sir? Yeah. Sweta madam, I will just call Kumarvel sir and come back, okay?
Yes, sir.
Kumarvel sir, are you here? Yeah, I will just call him, madam. Meanwhile, you can see this one. Dear participants, sir will join in 2 minutes. Sweta madam, please check whether sir is. If sir comes, please let me know. Okay.
Yes, sir.
Yeah, I will continue this. So that's all. So this is the great. I feel comfortable with making CV. Okay, whenever I get anything, maybe when conference. Now I am working as coordinator for this. I will immediately enter there only, and I feel very happy. Okay. Similarly, I have done some other things also. Even we have done syllabus also. Okay, syllabus contains.
Sir, good evening, sir.
Good evening, sir. Good evening.
This is Rammohan Reddy from Kadapa.
Tell me, sir.
I know I was interested to know about to draw the diagram, sir, in LaTeX.
Sure, sir. Sure. Diagram is we can draw diagram somewhere, sir, and we can bring that diagram into LaTeX, sir.
That is different aspect, sir. But we have to know the coordinates of the each and every line, sir. There is possibility.
Definitely, sir. Definitely. If time permits, I will continue here. I will tell here only. Otherwise,
Okay.
we can meet later, sir. No
Now
problem.
we can upload the image, no issue. But that is different issue. But we are able to draw. We are capable to draw the diagram in latex only.
If, of course, maybe, but I don't get. I mean, but I never faced that thing, sir. Actually, so I will draw the diagrams in MS Visio only. I will make it into TIF format, and I will call from the latex.
Sir, okay, sir. Okay, sir. Thank you.
Thank you, sir. Thank you, sir.
Sir, good evening, sir. This is Dr. G. Pantangareddy from Pulaya College, sir. Hello. Hello.
Kishore sir? Kishore sir? Kishore sir? Kishore sir? Sir, are you able to hear me? Participants, am I audible?
You are audible, ma'am, but Kishore sir is not in group.
Yeah, I'll just call him, sir.
Yes, ma'am, you are audible.
Good evening, all of you. Am I audible?
Yes, sir.
Yes, sir. You are audible, sir.
You are audible, sir.
Okay, thank you.
Raghu, sir?
Yes, sir.
Yeah. Sir, please introduce, sir.
Yes, sir. So, good evening, one and all. I'm Dr. Raghuvan. So today's speaker, Dr. Kumaravel S., working as an associate professor in National Institute of Technology, Calicut, Kerala. Sir has completed BTech in Bharatidasan University, Tiruchirappalli, Tamil Nadu, and MTech in National Institute of Technology, Tiruchirappalli, Tamil Nadu, and PhD at National Institute of Technology, Calicut, Kerala, PDF at University of Dublin, Ireland. Sir has published more than 40 journal articles and 67 conference papers. Sir has received Kerala State Award, Renewable Energy Award in 2018. Sir has received Best Paper Award and Young Scientist Award in 2017. So I welcome you, sir.
Yes, sir. Very good evening to all of you. I hope I am audible.
Good evening, sir. You are audible, sir. Please proceed, sir. Thank you.
So I think my screen is also visible, right?
Yes, sir. It's visible, sir.
Okay. So I think the first slide is not coming. Let me check it. I don't know. Yeah, it is coming here. I don't know why it is not coming. Sir, is my screen is visible? Any problem are you facing?
Yes,
it is
sir.
visible, sir.
Visible, sir.
Okay, right. So first, let me give a brief introduction to renewable energy sources. The given topic is promotion of renewable energy using smart utilization of renewable energy sources with the AI. That is a given topic. So you all know why we go to renewable energy, because of the problem we are facing in particularly in the conventional fossil fuel. I think particularly in the past 50 years, almost we have exploited more than 70 to 80% of the resources available in the entire world, particularly coal and oil. Apart from exhausting the energy resources, these fossil fuel creates a severe impact on atmosphere. Not only atmosphere, it also decides the economic status of any country. So, although we primarily depends upon electricity, particularly to meet our day-to-day activities, we are in the position to search an alternate options, particularly from renewable energy sources. So you all know the renewable energy sources, particularly solar PV and wind. These are the two promising renewable energy sources, play a vital role to provide electricity. Although there are different types, like hydrogen energy is another green energy which is highly promoted at present, and there are many research is going on. But however, the solar energy and wind energy is already on roll, installed in various places for electricity generation. Just a few background slides, let me proceed. You know, electricity was recommended as the fourth basic need of human, and let me see the backbone, especially how it evolved. Benjamin Franklin, you never ever forget him. So he proved the lightning experiment, it is flying cut experiment in 1752. Then Alexandra Volta invented the galvanic cell. Michael Faraday, before his invention, people were talking about only chemical energy and electrical energy controversially. Later, Michael Faraday proved that electricity can be correlated with magnetism. That is, rate of change of current causes rate of change of flux. Rate of change of flux causes rate of change of current. That is Faraday's law. You all know very well about Faraday's law. Then one more invention by Andre Marie Ampere. That is, when a current carrying conductor placed in a magnetic field, it experiences a mechanical force. That is, F is equal to BAL sin theta. So after this principle, almost electricity began its journey for society. So 1820, Andre Marie Ampere proved this, whereas in 1884, Thomas Alva Edison started his first power plant in the world called Peel Street Power Station. It was basically a coal-based power station. It was DC, in fact, 110 volt DC. He served almost 85 customers only for electrifying lamps, that is, providing light energy from lamps. Later, in 1882, September, he started the first hydroelectric power plant in US. As per the record, this was the first power plant started in India in the year 1897, called Sidrapong Hydroelectric Power Plant. You can notice a difference between the first two power plants and this power plant. Those two were DC, started by Thomas Alva Edison. The power plant started in India in 1897 was AC. It was not standardized. In fact, it was 2300 volt, 83.3 hertz. It was not standardized. The ratings and the parameters were not standardized at the time. But they used AC in the year 1897, not only in India, maybe throughout the world. I think maybe some of you might read the text, a book on war, current war between AC and DC. One side, Thomas Alva Edison stand with his DC. Other side, Nikola Tesla stand with his AC. A current war happened between 1882 to 1887, almost the period of 5 years. And later, AC won the current war. From 1887, almost more than 100 years, the entire world was revolved by only alternating current. The electricity was generated in the form of AC, transmitted in the form of AC, utilized also in the form of AC. All these entire power system made up of RLC, passive elements, resistor, inductor, capacitor. You take a load or a transformer or a transmission system or alternator, every component and device in the power system realized as an RLC component. And the wave shape was a sine wave, that is a single phase Vm sin omega t, in three phase Vm sin omega t, Vm sin omega t minus 120, Vm sin omega t minus 240. The load could be either a star connected system or a delta connected system in the entire power system. That was the only structure they followed almost for a period of 100 years of time. But now, if you ask a question between AC and DC, right? In 1887, the war was won by AC. But 2024, if you conduct a war between AC and DC, I don't think AC alone will win. AC lose its attraction. I think you all may agree with me. Generation was AC. People were using alternators coupled to a turbine of maybe a thermal station. They use a steam turbine, or a hydro station, water turbine, or atomic station, again steam turbine. Any conventional electricity generation method, if you see, it was AC. But now, if you see, we go for renewable energy sources. For example, solar PV is a DC source. We want to store energy now. Why? Because we would like to provide a reliable electricity. That too, after bringing computers and now UPS, most of the load we would like to provide a reliable electricity. So we depends upon storage. So battery is used as one of the major storage device. So battery belongs to DC. So solar PV is already a DC. Now, wind generator is concerned. We are using AC, PMSM or induction generator we use, but we cannot connect with the grid. Why? Because we have to synchronize it. So we have to convert AC into DC and then DC into AC. Again, DC is coming to the picture. Okay, if you talk about generation, slowly moving to DC. After some time, fuel cell also will join in the generation. That is also a DC. But transmission, now come to the transmission. HVDC transmission proved as a better technology than AC even more than 20-30 years before. When thyristors invented, people built HVDC stations. Today, transmission in terms of DC, much economy than AC. Right. DC transmission also gone. AC transmission also replaced by a DC transmission. Now, you know what is a transformer. Transformer is a typical AC device, but now people go for solid state transformer. Right? Now you know what is a transformer, solid state transformer. So what I would like to say, if you go to a power system, this is a power system structure. That's what I am talking. A generation converts from AC to DC, transforms AC to DC slowly. The centralized generation moved to distributed generation. Every home we integrate solar PV, battery. It forms a miniature version of a grid known as microgrid. Already low power, low rated wind integrated in the distribution system. The other side, I told the transmission system replaced to HVDC, and also wireless transmission getting much attraction today. Today, the distance between a primary coil and a secondary coil may be few millimeter to centimeter. Maybe in another few years, however, the technology developed in communication sector, similar wireless power transfer also will come to electrical. So by the time, transmission also will not be there. In HV DC, the wireless transmission also play a major role. You all know that load side, what are the changes happened, the conventional incandescent lamp replaced by LED lamps. It is a DC load. You have induction motor replaced by BLDC motor, again a DC load. Drives, solid state drives moving to PMSM and BLDC. Now induction motor almost replaced by the other special machines. What I would like to say, AC almost loses its attraction. DC slowly evolve. Maybe in future, DC as usual may beat AC. DC may again win the war compared to AC. But in the past 30-50 years, most of the things changed, right? TV become LED. LED TV, very cheaper and compact. No radio today. When we were childhood, we hear radio, but no radio today. Computer become tablet, and even mobile phone itself behave like a computer. Car, we have ultra modern cars. Telephone becomes cell phone. Everything changed, everything changed. Grid also changed. What is the grid evolution? Smart grid. Smart grid is one of the fine technology in the past 20 years. Most of the world immigrates from conventional grid concept to smart grid concept. when you see smart grid, it provide lot of flexibility in integrating low rated energy sources, highly non-linear loads like electric vehicle, bidirectional transaction of power. Like that, there are many advantages we get in smart grid. But in India, what is our smart grid? This is our smart grid, right? Many times I wonder how the technicians are managing this distribution system, particularly changes the so when you talk about India, this is our smart grid, right? I don't know how to convert this grid into smart grid. Government is making lot of initiatives stage by stage to modernization of the conventional grid. Lot of initiatives taken in the past 20 years, particularly in cities. Smart grid is really necessary at present, not only in terms of infrastructure, in terms of cost, efficiency, reliability, resilient wise. These smart grid really a better solution for our country. Now we are moving to renewable energy sources. Not only renewable energy sources, there are many storage technologies also combined with the renewable energy sources complement each other. Why a storage is important? If you have only a solar PV, we cannot succeed. Why? Because it is not available 24/7. Night time it is not available. So we should store it when it is available. Then we should provide a reliable power from storage. So a storage is a mandatory. Or maybe in the other way, if you ask a question, particularly solar PV is used in irrigation purpose. Suppose I have a 5 kilowatt motor. Assume that it is a DC motor. I have a 5 kilowatt solar panel, only solar panel. Suppose if I connect a 5 kilowatt solar panel directly to a 5 kilowatt induction motor, whether motor starts or not. Any response from audience? Please make it as interactive session. Then only it will be interesting to me. Otherwise, sitting in front of computer, assuming the participants are there in front of me, so speaking is very difficult. I hope participants are there or not, I don't know. Am I audible? Participants are there?
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Is it visible? Whatever I am speaking, is it audible, clear?
Yes, sir.
Yes, yes, sir. Yes, sir.
Very good.
Audible, sir.
Audible, sir.
I think all the participants also can respond me through chat box. But currently the chat box is blank. Just all of you say a hi message. Then yeah, some people are correct. Yes, yeah, very good. Some people are responding. Correct. Very good. Thank you very much for your response. So when you connect a 5 kilowatt solar panel directly to a 5 kilowatt DC motor, it will never start. Why? Because it needs some power to start to overcome the inertia. You know, usually a 5 kilowatt motor at least it takes 2 to 3 times its rated power. Suppose you have a rated current is 10 ampere. In transient, it will take at least 20 to 30 ampere current to start. Once if it starts in steady state, it will take the rated current. For example, you are telling 1 kilowatt at 100 volt. 1 kilowatt at 100 volt, the current rating is 10 ampere. What is the meaning of these parameters? 100 volt in steady state, 1 kilowatt in steady state. It is not meaning about the transient power. Okay. While design, you will consider the peak power into the picture because you have to start the motor with a maximum torque. That's a peak higher torque to overcome the inertia. Okay. I think you all know very well the torque of the motor in steady state is different. In transient, while starting is different. Okay. So because starting the speed is 0, while running the speed is rated. So the torque value differs. So what I would like to say, the 5 kilowatt solar panel is not sufficient to start a 5 kilowatt DC motor. Now, what we should do in the case of 5 kilowatt DC motor? So, will you able to go for 15 kilowatt solar panel? It is not sufficient. If you connect a 15 kilowatt solar panel, after all, to start a 5 kilowatt motor, there is no use. Economically, it is not viable. So, what you should do? You should combine a solar panel with a battery, a storage. Technically speaking, a storage. These two will complement each other, so it will solve the problem. Now here the storage is a must. Now you understood the necessity of a storage device. Okay. So renewable energy alone cannot do anything. Sometimes people says, okay, sir, why don't you connect to the grid? Grid also having lot of limitations, especially in Kerala. There are plenty of customers. They installed solar PV already in their home. In fact, some 5 years back, the rating of integration was I think up to 30% become 50%. Now it is 90%. Suppose you have 100 kVA transformer, you can integrate 90 kVA solar panel. Okay, but now in the past 2 years, that too after bringing electric vehicle, Kerala State Electricity Board is facing lot of problem. 100 kVA, many 100 kVA failure rate of the transformer increased. Failure rate of the 100 kVA transformer, particularly in the distribution sector, increased. Okay, I will come to that later. One side, although we are promoting renewable energy, the other side, the problem increased. So, we are in the position to go to a hybrid energy system. So, solar energy, you all know what is solar energy. By considering time, I am skipping all these things. Solar energy, the renewable energy, you all know very well because it's a small, what you would say, it's already a well-known technology. So I'm not going to the technology level. Solar PV, wind, biomass, and fuel cell, battery, ultra capacitor. These are the very popularly used energy devices at present in our generation. Right? Battery is there, solar PV is there. Many local generations. I think, is there any provision for our administration to unmute this sound? So thank you very much. I think the problem is resolved now. Thank you very much, sir, for your immediate action. I think I will proceed. So smart grid I already cover up. Now, how this artificial intelligence can help promoting renewable energy. That is our today agenda, right? Now I have given a brief introduction to renewable energy. I have started from the basic, the conventional energy, then why we go to renewable energy, what are the problems, then why we are moving from AC to DC, traction of DC. Then we discussed about the evolution of the grid, conventional grid to microgrid, DC microgrid. Then we discussed different renewable energy sources, its challenges slightly have introduced. Okay. Now we are moving to the next part of our lecture. So next part of the lecture will be talking about intelligence. That is our agenda, artificial intelligence. And let me talk. First of all, what is an intelligent? Because smart, the word smart and intelligence both have similar meaning, alternatively used in our literature. Intelligence. What is intelligent now? Before going to artificial intelligence, let me check what is intelligence first of all. Intelligence is adaptability to a new environment. Okay, you know, there are intelligence. Intelligence means some unique characters are there, unique characteristics. First and foremost characteristics is adaptability to a new environment. For example, if you bring a person maybe to India, for example, a person born and brought up in USA to India, for some period of time they will struggle, maybe language wise, food wise, culture wise, and later they will settle. That is called adaptability, you know very well. Similarly, when we go to some particular place, many changes will be there in terms of environment, food, language. Okay, but slowly we will change ourselves and finally we will adapt it to the environment. We face adaptation in many parts of our life, before marriage, after marriage. There is a big transition, right? So adaptability is the first and foremost characteristics of intelligence. That's why we are called very smart, no? Otherwise, how do you survive in life? So we are very smart. So next one, ability to evaluate and judge. That is called decision making. Suppose you are given with three choice A, choice B, C. For a given problem, you will definitely select a particular choice. Suppose if you are giving to other person, sometimes he may not take the same choice what you have chosen. It will change from person to person, problem to problem. So decision making is another unique feature of AI, of intelligence first of all. Next one, comprehend complex ideas. For example, you would like to travel from Chennai to Bangalore. Okay. Suppose if you are explaining to a person first time coming from Chennai to Bangalore, how do you explain him? Go to Chennai railway station, Chennai Central, catch a train to Bangalore, you say some number, then just board into the train. On the way, you will say Salem. many places, and finally you will reach Bengaluru. That's it. Say, although how you are explaining a problem from one person to another person, that is one intelligent system to another intelligent system, after all in a matter of 1 second, 1 minute, using some acronyms, comprehension. But if you are giving such an information to a machine, or if you develop a program for that, how complex it is. Suppose you are developing a program, what will happen? You have to each and everything you have to code, color, size, distance, time, many things you have to code, and even now such a machine is not invented, like a replacement to a human. Okay, so here the communication happen between one intelligent system to another intelligent system, where we are most of the time transforming a complex idea to others. In fact, when Einstein discovered the theory of relativity, most of the people never understood. But later, slowly, his theory is well understood to the public. Most of his theory was like that only. Okay. So what I would like to say, so in the intelligent system, although the idea is very complex, it can be comprehended and transformed from one intelligent system to another intelligent system. That is another important unique characteristics of an intelligent system. The capacity for original and productive thought. When intelligence is there, thought also will be original and productive. For example, ChatGPT. Everybody started using ChatGPT today. It is actually not a good practice. You should never recommend the students to use ChatGPT. It will spoil our education system. Okay. But sometimes, if an intelligent system started to think in its own way originally, what will happen? Like many movie released based on that, no, Terminator, and in Bollywood we received that Robo. Like that, many movie they released. If they started thinking in its own direction, what will happen? So intelligent system, sometimes the thought may be original. That is actually one of the threatening factor intelligence is concerned. Okay. Then ability to learn quickly. Machine will learn very quickly than a human. If you teach anything, it will learn very quickly. That is one of the well-proved thing in AI is concerned. Okay, learning from experience, yes. Another important, however a human learn things from experience. We are really learn from experience only. Similarly, a machine also can learn from experience. That is technically called as training. We are training intelligent system maybe to acquire the experience and knowledge. So these are the basic degrees required to be a system, to be an intelligent system. So if you create this artificially, it is called artificial intelligence. Okay, AI, artificial intelligence. That is adaptability, original thinking, originality, comprehending complex relations, decision making. These are the many main features of this AI. Okay. Especially why AI is required at present. In engineering domain, I'm speaking. Electrical, particularly in electrical, why do you need intelligence now? Because these are the capabilities of AI. What are the capabilities? One is non-linearity. It can handle a non-linear system effectively. You know what is a non-linear system? Particularly in electrical, all the systems are non-linear. You take a motor, non-linear. You take a power converter, non-linear. Everything is non-linear in electrical. If you go for a controller, we go for a PI controller. You know how tough to control a non-linear system using a linear controller. It is very difficult. But if you design an AI control, it can handle a non-linear system effectively. That is one of the usefulness and capabilities of AI. It treats a non-linear system as such. But what we do when you go for mathematics or control system, we convert a non-linear system into linear system. Then we go for transfer function analysis. Then we proceed to controller design, right? That's the way how we perform mathematics in our electrical system. But originally, a system is concerned in non-linear only. If you have a motor, it is a non-linear system. But in mathematical analysis, we convert non-linear into linear, then we perform the analysis, right? It is actually quite difficult and not accurate. Sometimes linear and non-linear system may lead an unbounded solution. Okay, you lose the stability sometime. So that is one of the major advantage of AI. If you handle a system to AI, it can handle very effectively than conventional linear controllers. Okay. It is like a black box model. System model is concerned, it is a black box model. Okay. So you may see one is a linear system, two is a non-linear system. Example I am showing. So this can be very effectively handled by an AI, which is always called as a black box model. We never bother about a system. Whatever ABCD constants, we never worry. We are only bother about input and output. That is called input-output mapping. Suppose you are going to teach how to use a remote controller to the elderly person. For example, assume that you are going to teach our elderly person means our grandfather or grandmother. If you teach how to operate a remote controller, how will you teach them? Take a remote, press button 1. It will generate a signal in 230 megahertz using a capacitive switch. Then it goes to a microcontroller or some signal processor. It converts this infrared signal, and this infrared sender transmit the IR rays to a TV, and the IR ray receive the signal. Then it is processed further. Finally, some Sun TV will come. Will you teach like that? Never. If you press 1, Sun TV will come. If you press 2, the other TV will come. If you press 3, Star TV will come. That's it. Okay. So why do you worry about what is inside the system? Who bother about the technology? Right. Elderly person is concerned, they least bother about the technology. What is your input? Press 1. Okay, KTV. Or press 2, Star TV. Some TV. Like, what is your input and output? We only bother about the input and output. We least bother about the system. That is called AI. Okay, AI least bother about the system. We train a system only from input and output. We do some data processing on input and output. Data is much important than a system here. Understood? So I told already adaptability. These are the usefulness application. In our electrical engineering, directly or indirectly, these are the few major applications we perform with the help of AI, artificial intelligence. Sometimes we go for modeling of a system using AI, parameter estimation, performance prediction or fault prediction, system control system problems, pattern classification problem. So these are any one or two applications we may deal maybe as a part of our research or maybe product level development. Many tasks we perform using AI, particularly in these domains. If you conduct a literature review, the first one and the fourth one well reported in the literature, because you know modeling is one of the major problem in our electrical. For example, I am telling you, if you say Ohm's law, what is Ohm's law? You all know what is Ohm's law, right? What is written in Ohm's law? V is directly proportional to I. What you say? At temperature remain constant, right? This is a 2-mark question. We teach as a 2-mark question. At temperature remain constant, voltage is proportional to current. This is Ohm's law. Can you show even a single electrical system where temperature is remaining constant? Can you show me even a single system where a temperature remain constant? Never. Then what is Ohm's law? What is the use of Ohm's law? Every electrical circuit we apply Ohm's law. Is it correct or not? Then it is wrong. Do you agree with me?
Yes, sir. Yes, sir. Correct.
Entire electrical engineering stands with Ohm's law only. Kirchhoff voltage law, whatever you write, Ohm's law is playing a major role. But can you ever show a single device where temperature is always constant in the entire process of operation? Switch on the supply till switch off 1 hour or 1 year or maybe any period of time. Whether even the temperature reaches a steady state, there is a transient period. Okay, even if it prolongs, temperature may reach a steady state value, but you never find it as a constant. Clear? Because if you take a system has 90% efficiency, it will always dissipate 10% amount of heat. The heat is with respect to temperature keep on increases. The temperature will never be a constant factor in any of our electrical circuit. Okay. Whatever the mathematical equation you are writing, it is practically invalid. Why? Because temperature will never constant. So, suppose, let me give another example. Most of the time, when you write an RLC circuit and you write Kirchhoff voltage law in time domain, and when you apply Laplace domain, what is assumption you are taking? With all initial condition to be 0. Is it true? Never. Then what about the Laplace transform based approach? Again, it is wrong. I think you all may agree with me. Every modeling problem in electrical is subjected to an approximation and some assumption. What is approximation? Temperature remain constant. The variation you are neglecting. Assumption, assume that temperature remain gone. Assume that all the initial condition to be 0. So that is a very dangerous thing in the modeling problem. Clear? So you should take actual model of a system and then you should model it. For this, for fun, let me say a small story. Actually, there was a school, they celebrated their annual day. For annual day celebration, they brought some 3 chief guests. 3 guests they invited. One guest is a physical director. Another guest is a mathematics professor. Other guest is a physics. Okay, physics professor. These are the 3 guests they invited for a function. Okay, the one who arranged the guest house and other facilities invited these 3 guests and accommodated in 3 rooms in a hotel. Okay, so next day was the function, and all the 3 guests arrived in a hotel. A professor from physics, a mathematics professor, and a physical director. These 3 people arrived. Okay. Now, the one who arranged accommodation supposed to arrange food. This fellow provided food in a container, 3 tiffin box he arranged. Unfortunately, he forgot to provide key to open the tiffin box, and he went to the home which is very far from the hotel. Okay. After going hotel, this fellow remembered, Adada, we forgot to give the key to open the tiffin box. It is very long from his home to the hotel, so he could not travel in the night. Early morning, this fellow awake. You can assume the mental condition of the fellow who arranged the accommodation for him for these 3 guests. He run away.
ಅವನ್ ಸಿಕ್ಕಿದ್ನ, ಅವನಿಗೆ ಹೇಳಿದ್ರಾ, ಫೋನ್ ಮಾಡಿದ್ರಾ, ತಗೊಂಡೋದ್ನಾ?
I think here also somebody started. Okay, they come to the story. So this fellow who arranged a room for these 3 guests rushed to the hotel. He entered into the first room where a physical director was nicely slept, and his tiffin box was opened, and he was just awaking some work, and he was doing some work. Then the fellow who arranged the room was very happy. He asked the physical director, hello sir, extremely sorry. Yesterday I forgot to give the key to open the tiffin box. How you had the food? This physical director told, it is very easy. I actually searching the key to open the tiffin box. Right from childhood, what you do? If you have tiffin box unable to open, just hit on the wall. Tiffin box will open. Same thumb rule I used. Just I hit on the wall, tiffin box open. I had my dinner. I slept nicely. So the organizer was very happy. He went to the next door. Who is in the next door? He is our physics professor. There also the tiffin box was opened, and he was nicely sleeping. His fellow awake, that professor, he conveyed the same thing, sir, extremely sorry, I could not provide the key. How do you open the tiffin box? This physics professor told, I'm very familiar about the shape and force. I know where to apply high pressure, where to apply low pressure to open the tiffin box. It was in a circular shape. I know how to apply a pressure. Once I applied a pressure, then tiffin box open. Because physics is a very good in shape and force. That's how he also happy. Now he went to the third door. Who is sleeping in the third door? Our maths professor. When he went to the maths professor room, this professor neither slept nor the tiffin box opened. He kept the tiffin box in the side and keep on doing some calculation. This organizer approached this professor. The professor, sorry, I could not provide the key to open the tiffin box. What are you doing? Very simple. I am doing some calculation. He is asking, what is the calculation you are doing, professor? Assumed tiffin box open. I started my calculation yesterday night till I am doing derivation to, I will solve it now. Like that, this mathematics professor was telling. Now, what do you understand? Assume tiffin box open. When you start a derivation, will it come to the end? Never. Okay. So at the same time, don't misunderstand me that I am criticizing mathematics. Okay. Although artificial intelligence evolved today, till now we depends upon the old Ohm's law only. We depends upon only this Laplace transform. The entire electrical was revolved by these equations only. We should not misunderstand or misinterpreted this mathematics, because mathematics is the queen of science. Without mathematics, engineering is nothing. Engineering will be empty. Okay, but how it is interpreted is the wrong thing. That's what I am indicating. Clear? I'm not criticizing mathematics. I'm identifying loopholes in the mathematics. I'm resolving those loopholes with the help of AI. That's it. Okay. So whenever you understood, please understand in the proper way. Okay. So you don't misunderstand. Clear? Sometime later you say that Kumaravel told that mathematics is waste. Not like that. Please don't misunderstand. All the mathematical equations are excellent, because still people are using Laplace transform and the Kirchhoff voltage law, Ohm's law, everything we use. But what is the loophole? Temperature remain constant. Assume all the initial condition to be 0. This loophole we are overcoming using AI. That's what I am trying to convey here. Okay. Similarly, a control problem, PA controller. You know what are the drawbacks of PA controller? How to improve the performance of a PA controller. That is our main role. Okay. So now you understood how AI can help to resolve the problem in the conventional system. That's what I'm highlighting here. Okay, these are various AI techniques like fuzzy logic, artificial neural network. Now it is called as machine learning, genetic algorithm, particle swarm optimization, simulated annealing, and the colony optimization. There are many names are coming up today under the topic AI, artificial intelligence. Okay, so this tool we directly or indirectly we are using. Here I'm going to nothing is coming. I don't know why nothing is coming. I think my slides are facing some problem, and let me just 1 minute. I'll come back. 1 minute. I'll come back. I don't know what is the problem I'm facing. I'll close and open it again. Yeah, I think now I'm sharing my screen. I think the screen is visible to you now. In fact, I have used application of AI in a power system domain, particularly to promote renewable energy sources. Here, what you see called a virtual synchronous machine. You know, I think all the electrical engineer definitely know what is synchronous machine. Synchronous machine has 3 windings in the stator and the rotating magnet in the rotor. If it is a permanent magnet, you know what is PMSG. If it is an electromagnet, it will be a salient pole and smooth cylindrical pole. We know very well about alternator, synchronous machine. Now, what are the advantages of synchronous machine? It will rotate in a constant speed and very easy for synchronization. Synchronization process, we see whether sequence are matching A, B, C or R, Y, B. Voltages are correct in magnitude between R, Y, B, all are equal in magnitude, and we follow the phase angle 120, 0, minus 120, minus 240, and then we see the frequency is at 50 hertz equivalent. Okay, if these parameters are satisfied, we just synchronize the alternator, and we adjust the frequency by controlling the flywheel governor mechanism, AGC, that is automatic generation control. Then voltage we control using AVR, automatic voltage restorer. Okay, this is the usual control of a synchronous machine alternator. Now, after integrating renewable energy sources, the inertia, the component of inertia is coming down. You all know very well advantage of inertia. Synchronous machine is one of such a good machine has an inertia. So, for example, let me say a machine has 100 megawatt, 100 MVA. A machine has a 100 MVA capacity. It is connected to a 50 kilowatt load. Assume that the transmission loss is neglected. A 100 MVA alternator is connected to 50 kilowatt load. Okay. Then what will be the generation of the 100 MVA generator? Can you respond me through chat box? Yeah. 100 MVA generator is connected to 50 kilowatt load. Okay, assume that the power factor is also unity. What will be the generation of the generator? Am I audible? Any one of you please respond me. Am I audible?
Yes, sir.
Yeah,
Audible.
yeah, very good. I'm seeing some answers. Very good. I think Dr. Kiran, I think Dr. Madhu, Dr. Dilip, thank you for your response. I think the answer is 55 megawatt. Yeah, 50 megawatt. 100 kilowatt is wrong. In fact, we sold 100 MVA, 100 MVA generator. If it is loaded with 50 kilowatt, the generation will be 50 kilowatt only, because generator, although it has a rated capacity is 100 kVA, 100 MVA, 100 kVA or 100 MVA, it will generate the power of 50 megawatt only. If it is 50 megawatt, it will be 50 megawatt. Okay. Assume that all of a sudden I'm increasing to 20 megawatt. Okay, it was 50 megawatt. Now I'm increasing totally a 70 megawatt. Now what will happen? It will maintain a stability. How it maintains a stability? Frequency will never, it will drop down, but it will never drop down quickly. Suppose if you take a frequency component, suppose assume that I'm drawing here the frequency component like this, assume that this is your time and this is your frequency F, you are maintaining at 50 kilohertz. Here, all of a sudden you are increasing the load. What will happen? Frequency gradually will fall down. Okay. Now AGC will come to the picture, it will restore, then it will go back slowly, then it will settle down here. Okay. So this is the unique feature of inertia. This is because this droop happens because of J. Otherwise, what will happen? It will fall down so quickly. The droop is decided, the slope of the curve is decided by the value of moment of inertia. If you have a large inertial system, the droop is very less. If you have lesser inertial system, the droop will be very fast. Particularly if you take solar panel or modern battery, it will never have rotating body. So the moment when it does not have rotating body, it will offer a lesser inertia. Now I already told what is advantage of an inertia. That advantage you cannot expect from solar PV. Okay, in a sudden moment it will lose stability. So the more and more solar if you integrate, the stability is very weak. The poor stability you get. That is one of the major problem the entire country is facing now. Although we are promoting renewable energy, because of this problem, we are not in the position to use the full capacity of solar PV. Okay. Particularly renewable, I am speaking. Now, this problem is resolved by many researchers, and this is one of the concept called virtual synchronous machine. How to provide a synchronous machine's inertia virtually. It is alternatively called a synthetic inertia, emulated inertia, virtual inertia. There are many names people are using in the literature. Synthetic inertia, artificial inertia, or virtual inertia. There are many names people are using. Here, I am calling it as a virtual synchronous machine. Okay. The construction wise, it has a battery and a bidirectional AC, DC to AC converter and a filter and a control technology. This control strategy all together called as virtual synchronous machine. Okay. You may ask how I have improved the performance of this virtual synchronous machine using an AI technique. Okay. Here what happened, the control of the synchronous machine is playing a major role. This is a detailed mathematics. By considering time, I am not looking into the detailed explanation. Here, this is a grid. This is a virtual synchronous machine. I'm creating some disturbance in the grid side. Accordingly, this virtual synchronous machine either will inject a real power or will absorb the real power, because I have a battery here. This power is bidirectional. Also, you have a capacitor bank in the DC bus, so you can control the reactive power also. So you can either control P, active power plus or minus, Also, you can control this reactive power plus or minus. If you draw a curve, something like this P and Q, you can operate anywhere in the quadrant. Anywhere in the quadrant. Positive power, positive reactive power, or positive reactive real power and negative reactive power. Anywhere you can operate. That is one of the unique feature of your virtual synchronous machine. Okay. So this is the hardware setup what we have done at NIT Calicut. So this is one of the publications what we have made with the help of an AI genetic algorithm for tuning PI. We have used PI controller in the virtual synchronous machine to control the modulation signal using the variation of damping power and the virtual synchronous power. We have a feedback system. The detailed mathematics actually I am not showing here by considering time. So we are approaching genetic algorithm for tuning the value of Pi. We have done an excellent work. And here you can see after tuning, the machine is performing very nicely with lesser oscillation. Compared to the conventional Pi and the genetic algorithm tuned Pi, genetic algorithm tuned Pi gives a better performance in terms of lesser overshoot and lesser settling time and lesser oscillation. All these parameters we have measured. You can see we have created a disturbance here. Okay. Still this autonomous system, and all of a sudden we move to grid connected system, we get a satisfactory performance here. This is a hardware result. Similarly, we have done a lot of analysis. Even we have changed the direction of power also from grid to battery and battery to grid. It is also giving an excellent performance. Okay. So all sort of analysis we have done. It was giving an excellent performance in the dynamic results we are seeing here. In fact, we have done a power hardware in loop analysis also. And extremely sorry, I could not explain in detail because of the heterogeneous group of participants. And based on this work, we have published a paper in IEEE transactions and energy conversion. At the end, I will share it in the chat box. You can also download, and when you have free time, you can read it. What I would like to say, there are many such power system problem even exist today. That problem we are solving using a modern approach called a virtual synchronous machine. Using AI techniques, we are improving the performance of the virtual synchronous machine compared to the conventional machine. And that we have proved using both simulation as well as hardware. In the hardware, we got a satisfied result. That's how the novelty was proved, the outcome was proved, and the target was achieved, and the paper was finally published in IEEE transaction on energy conversion. So I request each and every one of you, if you are a researcher, try to identify a problem in the grassroots level. Doesn't matter, it should be a power system problem or a power electronics problem or anything, and try to learn the conventional mathematical approach and the mathematical control technique or any conventional system, and identify a research gap or shortfall or further research, and approach AI technique, any AI technique, because plenty of AI techniques are available today. You can use a machine learning, you can use a fuzzy logic, any one technique you can use so that the performance of the system can be improved satisfied manner. In fact, now we are working on a CPRI project which was awarded based on the work what I am showing now. We are developing a product for a domestic system using this concept of virtual synchronous machine. Okay, so that is the good way of promoting academician in collaboration with an industry. We can do a miracle. That is really a major collaboration we required to understand industry. Industry will understand academics. So that's how we can create a win-win situation between an industry and an academia. Okay, so I suggest AI application in power system promotes the penetration of renewable energy, maybe plenty, which is highly required at present. Okay, with this, I'm coming to the end of my lecture. So thank you very much for providing me an opportunity to share some of my research expertise to all the audience. Although I have joined through online, I have tried my level best. I do not know whether I have fulfilled the expectation of most of the students, most of the participants. Sorry. If any questions, please bring it to my notice and make more interaction. So I will be happy, at least some of you understood the concept, what I have shown till now. So am I following the time actually? Whether I am stick on with the timing or not, I don't know. 7 o'clock, I think 7:30 I have started. I don't know what time I started. 7:30, I think, right?
Yes, sir. Yes, sir. You started
So,
it.
at what time I should stop? Please tell me.
9 o'clock, sir. 9 o'clock.
Oh, 9 o'clock. Yeah, almost time is going to be 8:40.
Yes, sir.
Please ask our audience to provide questions, because although I have shared some of the little idea, I have started with very fundamental. Slowly I moved to renewable energy. Then I came to promotion of renewable energy, problems what we are facing. I have taken a typical, some AI techniques also you have seen. And finally, I take a typical example, and then I have explained how an AI can help to improve the performance of a conventional system. Okay. So if you have any question, please bring it to my notice. I will share meanwhile the paper what I have published using this work. Okay. Yeah. In the chat box, I have shared the publications what I have made. The participants, please come forward for the interaction or questions. If you have any questions, please provide it. Or otherwise, you can also unmute and you can ask me. This is the paper what we have published.
Sir, sorry to disturb you. How you have built SVM, sir?
Madam, not clear, madam.
SVM. How you have built SVM? Synchronous virtual machines.
Yeah, virtual synchronous machine, madam. VSM. Virtual synchronous machine. Yeah.
Yes, sir. In which software you have used, sir?
Madam, I shown a block diagram. Virtual synchronous machine is not a software. We have a system called a battery storage and a power converter and a filter, and then we have a control strategy. Okay, all together called as a virtual synchronous machine.
Okay. Yeah. Okay, sir, got it.
Thank you, madam.
Thank you, sir. Thank you.
In this paper, we have well explained. In this paper, we have explained how we use fuzzy logic and how we have modeled this fuzzy logic, genetic algorithm tuning, most of the things we have explained. Fuzzy inference engine, how the stability is improved. If you look into the paper, a typical case study, you can understand how we proved this using hardware. All the things we have explained. Okay, this paper you can look into it. I can also share the paper with you. If you have time, you can look into this paper. This is one of the very good work what we have done in our lab. I think the fine evening, whether it was clear to you, I don't know how far it is. It was clear. Any other questions, please? Sir, if there is no other question, shall we wind up?
Yes, sir. Actually, we will take the photograph and we will wind up, sir.
Thank you, sir. Thank you for your thoughtful sessions. Participants, kindly switch on your videos.
Sir, my video is visible, madam?
Your video is not visible, sir. You please unshare your file, sir.
I don't know, madam. I shared my video. I do not know whether it is coming up.
It's not coming, sir.
Okay. I think it is revolving, madam. I don't know some problem or not.
Okay, sir. Please unshare your thing, sir.
Yeah, please go ahead. Shall I stop my presentation?
Yeah, presentation. Please stop. Yes.
Yeah, now I stopped my presentation.
Yes, sir. Yes, sir. Correct. So participants, please switch on your videos so that we can take photo.
Is it okay, madam?
Sir, it is not visible, sir.
Madam, I don't know what is the problem. Still, my video icon is rotating. It is not coming.
Okay, sir. Okay, sir. No problem.
Yeah, now it is coming, I think. Yes, video. Now I think it's coming. Yeah, please go ahead. Still, I have some problem. Please. Is it okay? Then shall I sign out?
Just a moment, sir. Kumarvel sir, thank you so much, sir. And Raghu sir, are you here?
Yes, sir.
Yeah, please give the vote of thanks, sir.
Thank you, sir. So thank you, Kumaravel sir, as a speaker, and thank you, Kishore sir, as a coordinator for FDP. So thank you, ma'am. Shweta ma'am. So thank you, ma'am. So Illusion sir, as a HOD of EEE Department. So JAIN GMTP University. So thank you, sir, and thank you all the participants.
Thank you, sir.
Kumarvel sir, thank you, sir. Thank you
Thank you,
so much.
sir. Thank you, all of you. Please allow me to leave now. Thank you all.
Yeah, sure, sir. Sure. Thank you, sir. Thank you so much. And dear participants, actually we have to take the photographs and we have to submit to ATAL. I request all of you kindly mute yourself while speech is going on. And I request all of you, please open your videos when we are asked to take the videos. Then it will be fruitful. At least we can have, because I am only taking the photographs and I can capture 8 in one time. So out of 8, I am hardly taking 2 to 3 photographs only. All other things are not at all coming, because videos you are not opening the video. Okay, so my sincere request would be, whenever we call for it, so please open the video, and please please keep yourself muted unless the chance has been given by the resource person. Okay, so please maintain that one. And whenever you have any doubt in between the lecture, so you can please post in the chat window. So we will definitely read the chat window, and resource persons will also read the chat window. Sorry. So they will definitely help you out. And I will take the PPTs of everyone and I will share it with you. Yes, yesterday we have shared. And if you have any more doubts, you can ask me regarding the continuation of this FDP. And regarding a latex session, you no need to worry. I will be with you for up to the last day also, and after that also I will be with you. So whenever you have any doubts or anything, you can directly message me. So not an issue. So please, participants, if you have any problem facing this FDP, please let me know so that we can rectify it. Okay, so if you don't have anything, we will wind up for today, and maybe we need to take feedbacks also. So definitely we will take the feedback at the end of the session. So participants, yeah, madam, please, madam.
Feedback link is shared in the chat box and WhatsApp group, sir.
Yeah, and moreover, I like to tell you, tomorrow onwards, we are sharing the feedback links through chat window only. Okay, so please fill the feedback links. Then only I can give you the attendance. Otherwise, I can't give the attendance. Understand? No? So please understand my pain also. So if see, first day 170 people have done the feedback form. Okay, they have filled feedback form, 170 people out of 196. So for those 26, I can give absent. That's okay. But if you come and if you are unable, don't fill, means it's not fair. Up to today, we will continue putting the feedback forms through our WhatsApp group. But tomorrow onwards, we don't keep in WhatsApp group. We will keep here only. My sincere request would be, kindly attend the things and fill the feedback form so that you will get the attendance. So please maintain this one. Okay, at least at the end of the session, if you come also, you will get the feedback form. Okay, so please fill it so that it feel comfortable for me also, because we can't take the attendance directly through GeoMeet. I'm sorry. So we are maintaining the feedback form only. Through feedback form, we are taking it. Okay, that can be done. No, not an issue. So please fill the feedback form so that you can get the attendance. And still, if any one of you are unable to join the group, okay, I am posting my phone number. Please contact me directly so that I can add you. Immediately I can add you. Okay, through WhatsApp you can share me. That means that such that I am not in the group, kindly add. I will add you. Yes, sir, correct. It's very informative. Actually, sir, I have I got the opportunity of Kumarvel sir. Actually, I went for one of the offline STTPs like this. Okay, it is at NIT Calicut. In NIT Calicut, they have done hardware lab also. Of course, offline means one hardware lab should be there. They made us to design one converter there. Okay, it was very excellent session on that day. So that's why I have identified Kumarvel sir. So his session is very good. So still, this is the starting point. Every time we are telling that point only. This is the starting point. Still, if you want to meet Kumarvel sir, tomorrow you can easily say that I have attended so and so sir. I want this help. He will definitely help you. Understood? This is the case. So with that note only, I call Kumarvel sir. Sir, I have attended your STTP. So I want you as the resource person. He immediately accepted. You know, he is a very busy person. Okay, I called around 4 to 5 times to him till date. Every time he is busy only. Every time he is busy, but still he accepted our invitation. So we are really grateful to him. So he has given that much time to us. So it should be utilized if you utilize it. So please try to utilize his services in one or the another way. So thank you so much for this session. Sweta madam, do you want to say something?
No, sir. I shared the link, feedback link. So kindly fill it up.
So feedback links were shared. So you can please go ahead with that. Okay, I will take the attendance tomorrow. So maybe by tomorrow I will update attendance of 2 days. So if still you want to, I mean, fill the form, you can fill. They are well available in WhatsApp group. But tomorrow onwards, I won't give this chance. Okay, please come here and take the feedback form and please fill it. Okay. So thank you so much for your kind cooperation. Please share the link. Which link you want, sir? Sudhir sir, which link you want?
Dr. Kishore sir?
Yeah, tell me, sir.
I am Dr. H.B. Suresh from JAIN College of Engineering, Shimoga.
Yes, sir. Tell me, sir.
The volume is too low, sir. It is a little bit increase in the volume is required. We are unable to hear properly the voice. For that, what arrangements you can made?
Entire session or any session?
No. What you are talking now, like that. So please make an arrangement so that it can be.
Kumarvel sir, speech is okay for you?
Yeah, everything is okay, but we have to concentrate more. Even though we have kept our volume to the maximum, it is not so.
Are you going ahead with mobile or laptop, sir?
Mobile, sir. Mobile.
Yeah, because sir, till now I have listened to Kumarvel sir's speech only. Okay, we found it is very nice only. Because I am using laptop. Maybe you may not using laptop. Maybe it may be mobile. Maybe you can check up with mobile once again, sir.
Okay.
Because
if there is any possibility from your end, or it is not.
We have done everything fine, sir. Because this complaint was not raised. Those who are using that what we can call laptops, it's fine only. Maybe you can shift to.
Okay.
Kishore sir, I want to add something. Like in mobile, it is low only, sir. So when I go for laptop, it is clear voice, ma.
Clear.
Can you use earphones so that it will be audible properly?
Okay, sir. Thank you, Kishore sir. Thank you.
You can use earphones, sir. Otherwise,
okay. Thank you.
Fine.
Sir, Kishore sir, this Raghavendra from NI Mysore. Sir, I'm having one request. You just extend the session what you did, that is latex.
Sure, sir. Sure. Whenever time permits, I will definitely.
Okay. Thank you so much, sir.
Yeah,
you have given wonderful informations.
Yeah, thank you, sir. Thank you so much. We have given to all speakers 1.5 hours, but generally they will speak for 1 hour because they want to speak the latest upcoming things, what they are doing. Because we have selected the real researchers, sir. So what they are doing, they want to explore. So definitely they will take 1 hour only maximum. So within that half an hour, we can cover in the next sessions also. Nothing wrong. Every time I will be with you only. No need to worry. So if you still want any more things, so you can call me. I can give you the things.
Sir, Presentations also you should show in
So
later presentations.
yeah, I will share that. I will share this. Yes, any more things to discuss?
Okay, thank you, Kishore sir. Thank you.
Thank you, sir. Suresh sir. Thank you so much.
Okay, thank you.
Thank you, sirs and madams. And if you find it is useful, then we are really blessed. And tomorrow's sessions, 2 more sessions will be there. We will post in the WhatsApp group what are the sessions.
Hello, sir.
Yes, sir. Yogesh, sir. Tell me, sir.
Sir, attendance is noted every day on ATAL website.
Yes, I thought of doing that, but yeah, maybe tomorrow. For these 2 days, I will do tomorrow, sir.
Okay, because I want to check the attendance is going as per we are present every day, but just for the sake of information, I want to see attendance is present or absent every day.
Sure, sir. Sure. Actually, if you fill the Google form, that feedback form, then attendance will be added.
Thank you, sir.
I will take Google form only. Yes.
Yes, sir.
Thank you, sir. Thank you so much. Thank you, sirs and madams, and thank you so much. And we will post tomorrow's poster also, so you can come to know who are speaking tomorrow. And if you have any preparation from your end, you can prepare and you can come for the sessions. Thank you. Thank you so much. Good night. Have a nice day.
Thank you, sir.
Thank you, madam. Thank you so much. You can end the meeting, madam. Okay, don't leave the meeting. End the meeting.
Yes, sir. Yeah. Thank
Yeah.
you, sir. Good night. Yeah.
Thank you, sir.
Have a nice day.
Good night.